Welcome to this lesson on colligative properties, part of our solutions series. Colligative properties are a fascinating topic in chemistry that reveal how adding solutes to solvents changes the behavior of solutions. What makes these properties special is that they depend only on the number of particles present in the solution, not on what type of particles they are. This fundamental concept helps us understand everything from why we salt icy roads in winter to how our cells maintain proper water balance. Let's define what we mean by colligative properties. The term colligative comes from the Latin word meaning collective. These are properties of solutions that depend only on the number of solute particles dissolved in the solvent, not on the type or identity of those particles. In other words, if you dissolve 1 mole of any substance in water, the effect on colligative properties will be the same regardless of whether that substance is sugar, salt, or any other compound. The key factor is the particle count, not the chemical nature of the particles themselves. The fundamental principle behind colligative properties is simple but powerful. Particle count matters, not particle type. To illustrate this, consider dissolving 1 mole of glucose in water versus 1 mole of sucrose. Even though glucose and sucrose are completely different molecules with different structures and different sweetness levels, they produce the same effect on colligative properties because both contribute the same number of particles to the solution. This is what makes colligative properties so useful for determining molecular weights and understanding solution behavior. There are 4 main colligative properties you need to know. First is vapor pressure lowering, where adding solute particles to a solvent reduces the vapor pressure of the solution. Second is boiling point elevation, which means the solution boils at a higher temperature than the pure solvent. Third is freezing point depression, where the solution freezes at a lower temperature than the pure solvent. And fourth is osmotic pressure, which is the pressure that results from solvent molecules flowing through a semi-permeable membrane. Each of these properties changes in proportion to the number of solute particles present. Colligative properties depend on the concentration of solute particles, and we measure this concentration using molality. Molality, symbolized by lowercase m, is defined as moles of solute per kilogram of solvent. The formula is molality equals moles of solute divided by kilograms of solvent. We use molality rather than molarity because molality doesn't change with temperature, since it's based on mass rather than volume. All 4 colligative properties are directly proportional to the molality of solute particles in the solution. When discussing colligative properties, we must distinguish between electrolytes and non-electrolytes. Non-electrolytes, like sugar or glucose, dissolve in water but remain as intact molecules. Each formula unit produces just 1 particle in solution. Electrolytes, on the other hand, are substances like salt that dissociate into ions when dissolved. For example, sodium chloride separates into sodium ions and chloride ions. Because electrolytes produce multiple particles per formula unit, they have a greater effect on colligative properties compared to non-electrolytes at the same molality. To account for the dissociation of electrolytes, we use the Van't-Hoff factor. Symbolized by the letter I, the Van't-Hoff factor is defined as the number of particles formed divided by the number of formula units dissolved. For non-electrolytes like glucose that don't dissociate, I equals 1. For sodium chloride, which dissociates into 2 ions, I equals 2. For calcium chloride, which produces 3 ions, I equals 2. The Van't-Hoff factor allows us to correctly calculate colligative properties for both electrolytes and non-electrolytes by accounting for how many particles are actually present in solution. Let's summarize the key takeaway from this introduction to colligative properties. The essential concept to remember is that colligative properties depend on how many particles are present in a solution, not on what type of particles they are. Whether you're dealing with molecules or ions, large particles or small ones, polar or nonpolar substances, the colligative effect is determined solely by the number of particles. This principle underlies all 4 colligative properties and is fundamental to understanding solution chemistry. In upcoming lessons, We'll explore each of these properties in greater detail and learn how to perform calculations using them.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.